Okay, for topic 5, we're going to look at finding the equation of a hyperbola. We're also going to revisit the idea of eccentricity. So remember, with an ellipse, eccentricity kind of told us like how much does an ellipse deviate from a circle? Okay, so like, is it super squished and oval or is it like kind of round and chubby? Okay, we have that same idea here with a hyperbola. Okay, I forgot to bold print definition, but eccentricity of a hyperbola, okay, refers to the value that describes how open or how stretched out the hyperbola is. The eccentricity is going to be a value greater than 1, and I can explain why in just a bit. But basically, you can have a hyperbola that kind of is like this, or you can have a hyperbola that's kind of like this, So like you can have them that are sort of like a little bit more squished or a little more open. Okay, so that's what the eccentricity is going to tell us here. Okay, now eccentricity is denoted by E. We already know that from the previous section. And it's calculated as the ratio of the distance from the center to a focus, denoted by C, divided by the distance from the center to a vertex, denoted by A. Okay, and we use the formula C over A. Okay, so that's the same formula. We don't have like a new formula for it. It just kind of means something a little bit different when you're talking about a hyperbola. Now, we also know that the distance or the length C is always the biggest one when we're talking about A, B, and C. A is the distance from the center to the foci. A is the distance from the center to the main vertices. And then B is the distance from the center to the co-vertices. So because C is always going to be bigger than A, because like if you can kind of envision this right here. All right, this is our center. We have negative A, we have positive A, and then we have our foci that live kind of inside those curves. So that's negative C, this is positive C. The distance to C is always going to be longer than the distance from, well, the distance from the center to C, or to a focus, that length C is always going to be longer than the distance from the center to a vertex, which is that length A. So this is always going to be greater than 1, okay? Now, what we're going to do in examples 4 and 5, not terrible, okay? Several steps. We got to find some important points, but it's the example 6 it's going to take us a while to get through example 6. It's a long, long example, so just know that none of the steps are necessarily difficult, it's just a bunch of them, okay? So for example 4, it says, write an equation for the hyperbola, sketch the location for each focus point, state the eccentricity. So I don't think I'm really gonna, well, we'll definitely sketch the location for each focus point, okay, because we don't have them here, so we can do that. But we got to find a lot of information from this, and some of it's pretty easy, some of it's kind of like given to us in a sense, and then some other stuff we got to work a little harder at, okay? So we need a center. We like having a center. Okay. So where is our center? Luckily, it was given to us pretty point blank. So you can see here, they're kind of using that rectangle method that I've shown you for graphing, where we draw a box from our co-vertices to our main vertices. We draw like a little box encompassing all of those. And then we have our asymptotes that kind of crisscross through the center through those boxes. Okay, so the center was given to us. Okay, so the center we can see from the origin, we went out 2 and then we went up 1. So our center is the point 2, 1. Okay. We also have the vertices. We can see that from the center, we went back 1, 2, 3 units, and then we went forward 1, 2, 3 units. So the vertices have a distance or a length of, well, they don't have a distance, but from the center to the vertices, we have like a length of 3 units, okay? But we need to know the actual ordered pairs here. So for the leftmost vertex point, we go from the origin to the left 1 and up 1. So this is the ordered pair, -1, comma 1. And then to get the rightmost vertex from the origin, we go to the right 5 and then up 1. Okay, so we've got some really important points so far. We need to find the co-vertices if possible. So remember, the co-vertices are directly above, in this particular case, because of the way this is oriented, they're going to be directly above the center and directly below the center. So what is this point here? And then this point here. Well, to get to those 2 points, we would start at the origin. We would go to the right 1, 2, and then up 1, 2, 3, 4, 5. So that's the point 2, 5. And then this one is going to be the point 2, comma, let's see, we go 1, 2, -3. Okay, so we've got some really, really important points here. Using the vertices and the covertices, we can find values for A and we can find values for B, and that would allow us to find values for C, which would then give us the ability to find the foci. Okay, so let's talk about our vertices. Okay, well, our vertices are -1, 1, and 5, 1. Now, depending, you can go about figuring out what A is, however you like. The distance from one vertex to the second vertex is always 2A. So if we can find the distance between the two vertices, we can figure out what A is. You could also go about this from the center. How far are each of the vertices from the center? Okay, either way you can get A. So if we're looking from the vertices, okay? To get from -1 to +5, we would have to go 6 units. So we could say, well, 2A equals 6, divide both sides by 2, we get A equals 3. Okay, we know what A is. You could also say, well, to get from the center to either vertex, I would have to move either left or right 3 units. Doesn't matter how you slice it, A is 3. Now, for the covertices, we have ordered pairs of 2, -3, and 2, 5. So what would I have to do to get from -3 to 5? Well, I would have to go 8 units total. So I could say 2 times B equals 8. Divide by 2, divide by 2, we get that B is equal to 4, okay? Or you could just think about this very logically. From my center, how do I get to either of those covertices? Well, I would have to go up 4 or down 4. Either way you slice it, there's a few ways you could go about this. I think just counting is the easiest. So we've got A and we've got B now, okay? Now, let's go ahead and talk about the foci, okay? So we know for the foci, we need C, okay? And we don't have C, but we have enough information to get C. We need to remember that C squared equals A squared plus B squared. This is the Pythagorean relationship with a hyperbola. And so C is really just the square root of A squared plus B squared. Well, A is 3, so we get 3 squared. B is 4, so we get 4 squared. So C is the square root of 9 plus 16, which is 25. So we get that C is now 5. Okay, so how in the world do I figure out what the foci are? Well, we can always go from the center. Okay, so from the center, because this has a horizontal transverse axis, I need to play around with my x coordinates of my center. Okay, so we could say, okay, we're going to take H. Remember, the center is really generically HK. So we're going to take whatever that H value is, which is the x coordinate of our center. We're going to add and subtract whatever C is, and then we're going to keep K the same. So this is going to be 2 plus or minus C, which is 5, comma 1, which is K. So the foci are going to be, well, 2 minus 5 is -3. So we get -3, comma 1. And 2 plus 5 is 7. So we get 7, comma 1. And those are the foci. So let's go ahead and plot those in a different color because this says write the equation for the hyperbola, sketch the location of each focus point, state the eccentricity. So we've got the foci, the focus points. We can do that really, really easily. The eccentricity is really, really easy. And then believe it or not, getting the equation isn't going to be half bad either. Okay, so let's go ahead and say, hey, these are the focus points. So we're going to go from the origin. We go back 1, 2, 3, up 1. We'll call this just F1 for focus 1. And then from the origin, we're going to go to the right 7 and then up 1, and we'll call that F2. So we have plotted the 2 focus points. Eccentricity is not bad at all. You need C and you need A. So eccentricity, we know that is E equals C over A. So we can say E equals 5 over A. What was A? 3. So that is the eccentricity. And again, it's going to be a value greater than 1. So if you wanted to, you could write this as a decimal. I'm just going to leave it 5/3. Okay. Now, the last and kind of probably the most important thing is what is the equation? Okay. Well, generically speaking, we know that we have a center that is not the origin. So we're going to get x minus h, y minus k. But we have to figure out which of those terms is going to be positive and which is going to be negative. Now remember, if the x term is the positive term, this is going to have some kind of horizontal transverse axis. The hyperbola is going to open in the x direction, okay? If the positive term were the y term, we would have a vertical transverse axis, which means the hyperbola is going to open in the y direction, okay? We're definitely opening in the x direction, so we're looking for something of the form x minus h squared over a squared minus y minus k squared over b squared equals 1. So let's go ahead and fill it in. We've got everything we need, okay? I'm going to scroll up just a teensy bit. Okay, so we have h and k. H is 2, k is 1. So we're going to go x minus 2 quantity squared all over. Well, we want a squared. A is 3, so we're going to get 3 squared, which is 9, minus y minus k. So that's going to be y minus k is 1, so y minus 1 quantity squared over b squared. Since b is 4, we're going to get 16, and then it all equals 1. So let's highlight and make sure we did everything. We've got the equation. We found the focus points. Write the equation and state the eccentricity. So we've got everything. I think we did it. Okay, so it's not the hardest thing. You've got several ways you can find A and B. Truthfully, we just kind of counted. We went for it, okay? If you wanted the equation of the asymptotes, you could get those. I don't know that we necessarily need that, but if you want to go ahead and think about the asymptotes, remember the asymptotes are at y minus k equals plus or minus b over a, comma, or not comma, times x minus h. So we could say the asymptotes are y minus 1 equals plus or minus 4 over 3 times x minus 2. And I would honestly just leave it like that. You could solve for y, but I don't think it's totally necessary. I would leave it like that. Okay, so we've done a ton. Let's move on to the next example. So example 5, it says find the standard form equation for the hyperbola described below. All right, we have vertices at 5, 3 and at negative 7, 3. And then we have a conjugate. Be very careful here. We have a conjugate axis length of 10. Okay, so let's plot the vertices and we can figure out kind of how this God bless, I said it again, how this hyperbola is oriented. Okay, so we have the ordered pairs 5, 3. So that's one of the vertex points. And then we have negative 7, 3. That is another, bless it. That is another vertex point. All right. So we can say that this is definitely going to have a horizontal transverse axis. Okay. So horizontal transverse axis. Okay, so vertex 1, vertex 2, and then we're going to have some kind of horizontal transverse axis kind of doing this. All right, we're going to have a conjugate axis that goes perpendicular to this through its center, and it's going to have a very specific length of 10. So we'll use that in just a minute. For now, let's figure out what the center is. Now, you could play around and you could just count off until you get to the center, but we do have something called a midpoint. We know the center lies directly in the middle between the two vertices. So you have this midpoint formula. It's something that we almost never use. So I think the math teacher in me is like, hot dog, we have a reason to use it. Okay, you can really just logic this one out. I'm just dying to use this one. So you take your x's, divide by 2. You take your y's, and you divide by 2. And this is going to give us our center. So the x's, we have 5 plus negative 7 over 2, comma, 3 plus 3 over 2. So let's see, 5 plus negative 7 is negative 2. Negative 2 divided by 2 is negative 1. 3 plus 3 is 6. 6 divided by 2 is 3. So we use something that I haven't had the opportunity to use in a minute. We have our center. So our center is going to be at the ordered pair, negative 1, 3. Okay, so that tells me my conjugate axis is going to be running like this. Okay. But here's the thing, the conjugate axis has a very specific length of 10. And there's, you could play around with this and find different ways to find this. I think we should just take our center, and we know the conjugate axis is running perpendicular to the transverse axis. And since the transverse axis is horizontal, the axis perpendicular to that is the conjugate axis, which is going to be vertical. So what I would do is I would just take, basically, let me start this again because I was kind of jumping ahead. We know the conjugate axis has a length of 10. Okay. We also know the conjugate axis is like the distance between the co-vertices. Okay. And the co-vertices are a distance of b units from the center. So if I go from the center to the first co-vertice or co-vertex, I'm b units away from the center, and then I go b units in the opposite direction. So I could also say that the conjugate axis is going to be 2b. Well, these two things, we can just set them equal to each other. So I can say, well, 2b equals 10. So obviously half the distance of 10 is 5, but we've proven it algebraically. So we can now officially say, well, b is 5. We might need that in a minute anyway. Okay, so since b is 5, I'm going to take my center, remember, and we just add or subtract b. So my co-vertices, okay, we always take the center and we add or subtract b from either the x-coordinate or the y-coordinate. Since my conjugate axis is running, since my conjugate axis is running vertical, I want to play around with the y-coordinate. So I'm going to leave h alone, and then I'm going to take k and I'm going to add or subtract b. So that tells me that I'm going to get h, which is -1. And then k is 3, and I'm going to add or subtract b, which is 5. So my co-vertices are going to be -1, comma. Well, 3 minus 5 is -2. And then I'm going to get -1, and 3 plus 5 is 8. So those are the co-vertices. Okay, so I can plot those pretty easily. -2 and then 8. So now this distance from here to here is exactly 10 units. Okay. So we've got a lot here. We've got B, we've got A. Do we know what A is? We can figure out what A is. We know what our two vertices are, so we just need to find the distance between the two or figure out how far away from the center we are. So remember, our center is the ordered pair, -1, comma 3. Okay. Our vertices are at 5, comma 3 and at -7, comma 3. So how far are each of these points from the center? You can just count. There's a few different ways you can do this, but you can just count if you want to. So to go from -1 to -7, I would go back 6. Okay, and to go from -1 to 5, I would go forward 6. So we can now say, hey, you know what? A is 6. Okay, there's other ways you could find it, but that's going to be the easiest way, just sort of count. You know the two vertices, you know the center, so we know what A is. Okay, so now what do we want? We want to figure out the standard form of the equation. I think we've actually got enough information where we could do it now. I don't even think we really need the foci at all. Okay, so we have to play around with this. We know that we're going to either need the X or the Y first, okay? And it all depends on how this particular hyperbola opens up. So we're going to have a hyperbola that's kind of doing this, okay? So we know it's opening in the X direction. So we're going to have X minus H quantity squared. That's going to be our positive term all over A squared minus Y minus K quantity squared over B squared equals 1. So now all we have to do is fill in those values. We know what H and K are. We know what A and B are, so we're in business. So we get X minus H, so X minus -1 is going to be X plus 1 quantity squared. A is 6, we want to square that, so that's 36. We want to subtract Y minus K, so Y minus 3 squared all over B squared, which is 5, so 25 equals 1. So that is the equation that we're looking for. And does it ask for anything else? I don't think it does. I think we're good. If you wanted to find the foci, you could. You'd have to find out what C is. If you wanted to find the asymptotes, you could. You could play around with that. If you wanted to find the eccentricity, you could. You would just take C divided by A. We don't have C yet. We didn't really need it. We didn't need the foci. But you could do a little more work and get more information. But for now, all we were asked to do here was find the equation, and y'all, we did it. All right. Next up is the one that's going to take a while. This is the long one, okay? And this asks for like everything, okay? So it says, show that the following equation is a hyperbola. The good news is when we get to section 7.5, there's an easier way to show that something is a hyperbola, a parabola, a circle, or an ellipse. All right, but for now, we just got to like brute force it. So we're going to show that this is a hyperbola. So we want to kind of play around and see if we can get this into some kind of standard form, okay? And then we're going to state the center, the vertices, the foci, the asymptotes, bless it, and the eccentricity. This is a long problem here, okay? So do you remember when we were talking about an ellipse, we had this problem where we had to complete the square, but we had to factor first. We're going to have to do that here, but we're going to have to do it twice, okay? So let's play around here. We're going to rearrange this equation first. Let's get the x's together and the y's together. So we've got 4x squared minus 16x. I'm going to leave a little space. And then we've got plus negative 9y squared minus 72y. I'm going to leave a little space equals. We want to take this minus 164 and we want to move it to the other side. So we're going to add 164 to both sides. But whatever we add on the left, we have to add on the right. So we got to leave a little space to add a couple of things. Okay. And we have to be very careful about what we add on the right. Okay. So in order to complete the square, the coefficient of the squared term has to be 1. We don't have that in either case. And then to actually do the completing the square, remember we take b over 2 and square it and add it to both sides, okay? So the first thing we have to do here, let's just focus on the x's for now. We need to factor out a 4. We need the coefficient of the squared term, x squared in this case, to be just 1. So I'm going to factor a 4 out front, and that's going to leave this as x squared minus 4x. But we have to be very careful. So whatever we add over here on the left, we have to multiply it by 4. So whatever I add right here, I have to multiply it by 4 over here because remember, we factored this 4 out. So it's kind of like we divided that 4 out. So to get the true value, we have to multiply on the right by 4 times whatever we add. All right, so let's think about it. So in this case, b is negative 4. So we want negative 4 over 2 squared. Well, that's just negative 2 squared, which is 4. So I'm going to add 4 inside the parentheses. And then on the right, I'm going to add 4 times 4. Okay? And then we're going to go to the y's. So this time I need to factor out a negative 9. And so because we're going to factor out a negative 9, we've got to be really careful with our signs. I'm going to write this as minus 9 and then parentheses. Negative 9y squared divided by negative 9 is positive y squared. And then negative 72y divided by negative 9 is plus 8y. And now we're just about ready to add, okay? So let me go ahead and do 4 times 4. All right, let's do a different color here. Let's do maybe green, okay? So now when I do the b over 2 squared, in this case, b is 8. 8 divided by 2 is 4. 4 squared is 16. So I want to add 16 inside the parentheses, but over on the right when I add the 16, remember, 16 has to be multiplied by 9. Okay, so we're going to add 9 times 16. Okay. Oh, wait a minute. It's negative 9. Hold on, let me fix this. All right, because we have a negative 9 out here, when I distribute that negative 9 back through, that actually makes this negative 9 times 16. Be very careful. Please check that sign and make sure you've got the negative 9 on the right. So negative 9 times positive 16. Okay, so now we can do the factoring part. So for the x's, I've got my 4 on the outside, and then inside I just get x minus 2 quantity squared. Okay. For the y's, I've got my 9 on the outside, my minus 9 on the outside. Inside, I'm going to get y plus 4 quantity squared. And then on the right, let me just double check. I think I know what it is, but let's double check it. So I've got 164 plus 4 times 4, 9 times 16. We get 36. That's what I thought it was. All right. So we're getting somewhere. We're not quite in standard form, but we are close. If we could turn this 36 into a 1, we'd be in business. So let's go ahead and divide all of the terms by 36 and simplify. Okay? So when I do that, the first term, that 4 in the numerator is going to divide into the denominator 9 times. So that's going to give me x minus 2 quantity squared over 9 minus the 9 in the numerator for the middle term is going to go into 36 4 times. So it's going to leave me with y plus 4 quantity squared over 4. And then that's all going to equal 1. So we have found the equation. It took us a good bit of work, but by golly, we found it. Okay? Now we have to find the center. The center is a piece of cake. So the center, remember, is always going to be of the form h, k. Well, h is what we subtract from x. X is our first term here, so we're subtracting a 2. Y is what we subtract from, or k, excuse me, k is what we subtract from y. So if we have y plus 4, to write that as a subtraction, it would be y minus negative 4. So our center is at 2, negative 4. So we could go ahead and plot that. So we're at 2, negative 4. That's our center. Okay, now we do know a lot more. We know that the x term is positive. And if the x term is positive, what that tells us is we have a hyperbola that's opening in the x direction. Okay, so this tells me the transverse axis is horizontal. Okay, and we know the transverse and the conjugate axis, they're going to go through the center. So the transverse axis is going to be, it's going to be the horizontal line through the center. So it's going to be y equals negative 4. That means the conjugate axis is running perpendicular to that. So the conjugate axis is going to be vertical, and it's going to be through x equals 2. So we can sketch those really quick. Let's do something that pops a little bit. Let's do red. So we've got our conjugate axis. We can kind of tweak it and clean it up a little bit, but we know that they're going to be running something like this. Okay, so along that transverse axis, the horizontal one, we're going to have our vertices and our foci, and then along the vertical axis, the conjugate axis, we're going to have our co-vertices. Okay, so let's go ahead and work on the vertices. Okay, some giant bug, what it was like a dragonfly or something, tried to kill me. All right, so let's look at vertices. Now, we can always start with our center, so we can go left, right, up, down to get to our vertices and our foci. In this case, the transverse axis is horizontal, and the transverse axis is what is going to hold those main vertices and the foci, or the focus points, okay? So because that's the horizontal axis, we need to play around with the x values from the center, so the x coordinate from the center. So my vertices are going to be h plus or minus a, comma, k. My co-vertices are going to be the opposite. So the co-vertices are going to run along that vertical axis. That means we need to play around with the y's. So my co-vertices are going to be h, comma, k plus or minus b. And then the foci, or the focus points, those are going to be along the transverse axis, which is going to be that main horizontal axis, okay? So that means to go from the center, we need to tweak our x coordinates from the center. So we're going to get h plus or minus c, comma, k, okay? So we know that we can really easily find a, we can really easily find b. We got to do a tiny bit of work to find c. So let's go ahead and do that. Okay. I can do it right here. So we know we need a for the main vertices. So a is the square root of the denominator of the positive term. So the positive term was x. The denominator is 9. We want the square root of that. So a is 3. So we're going to get h, which is, what was our center here? Our center was, where did I write this? Oh, it's literally right above me. The center is 2, negative 4. So our vertices are going to be at 2. plus or minus 3, comma, negative 4. So we're going to have vertices, well, 2 minus 3 is negative 1, and then negative 4. And we want 2 plus 3, which is 5, comma, negative 4. So those are our main vertices. We can go ahead and plot those if we want. So we want negative 1, negative 4, and 5, negative 4. So those are our main vertices, okay? Now the co-vertices, we need b, okay? So b is always going to be the square root of the denominator of the negative term. So in this case, that was our y term. Our denominator was 4. We want the square root of that, which is 2. So we're going to have vertices of 2, comma, well, k was negative 4, so we want negative 4 plus or minus b, which is 2. So we're going to have vertices of 2, comma, negative 4 minus 2 is negative 6. And then we're going to also have 2, comma, negative 4 plus 2 is negative 2. So we've got our co-vertices. We can go ahead and plot those. So we're going to be at 2, negative 6, and then 2, negative 2. Okay. And then finally, we need C. And C is always going to take a tiny bit more effort to find it. It's nothing like terribly crazy, but it is going to take a little more work. So remember, the Pythagorean relationship is C squared equals A squared plus B squared. And we found that if we square root both sides, C squared, or C is equal to A squared, the square root of A squared plus B squared. So we get the square root of 9 plus 4, which is the square root of 13. And we're going to plot these, so let's go ahead and estimate them. So the square root of 13 is 3.61. We'll just say 3.6. About. So it's approximately 3.6, okay? Now, for the actual ordered pairs for the foci, I'm going to use the square root of 13, but when I go to plot it, I'll use that 3.6. Okay, so the foci, we know that C is now square root of 13. It's going to be H, which is 2 plus or minus the square root of 13, comma, K, which is negative 4. So that's going to give us 2 minus the square root of 13, comma, negative 4. And then 2 plus the square root of 13, comma, negative 4. That's officially like what I would type into my Pearson homework, okay? But when we go to plot it, we'll tweak those just a smidge, okay? We'll use the 3.6 in just a bit, okay? So let's see here. If I wanted to do the estimated ones, we'll put those down here. We're going to get 2 minus 3.6. So 2 minus 3.6 would be negative 1.6, comma, negative 4. And then if I did 2 plus 3.6, that would be approximately 5.6, comma, negative 4. So I guess we can go ahead and plot those. And let's plot those in red just so they pop. So we go negative 1.6, comma, negative 4, maybe about there. And then 5.6, I don't know, roughly there. Okay. So we've got a lot of information. The directions told us to find the equation. Oh, shoot. Told us to find the equation, the center, the vertices, the co-vertices, the foci. We've got all of that. We also, I am getting eaten alive by bugs. I forgot how miserable it was to have the doors open with this light on. Okay, we need to find the asymptotes and the eccentricity, and then we'll sketch this. So we're really, I promise, super duper close. Okay, so eccentricity, we'll squeeze it in. Ooh. Eccentricity, we'll squeeze it in right here. So eccentricity, remember, it tells us like how open is our hyperbola. I don't know what I just spelled, but it was not eccentricity. Eccentricity. And it is the equation or the formula E equals C over A. Well, C was the square root of 13. A was 3. So we're going to get the square root of 13 divided by 3, which is approximately 1.2. So we would say the eccentricity here, it's about 1.2. Okay. Now the asymptotes, remember for the asymptotes, I don't know what just landed on me. Oh my God, get off of me. All right, so for the asymptotes, we have y minus k equals plus or minus b over a times x minus h. So we can just fill these values in. We don't even really have to simplify this formula. So k was negative 4, so we're going to get y plus 4 equals plus or minus. B was 2, a was 3, and then we get x minus 2. So those would officially be our asymptotes, okay? Now, let's graph this puppy. So we want to sketch our little box. So let's sketch our box in, I don't know, blue. We know the asymptotes run through the centers and through the corners of this little rectangle. Now we have the formula for the asymptotes, but I'm not going to get too bent out of shape about that. So there's our box. We can easily now draw in our curves. We've got enough guidelines. So we want to go from the vertices like so. Now, if you have made it through this problem, you need to celebrate and pat yourself on the back. This one was a doozy, okay? And I do think for the sake of time, because it is so late and these bugs are absolutely driving me nuts. We've got one more example. I think I'm just going to steal a video that somebody else did solving the same problem just because the bugs are like starting to flip me out a little bit. Okay. So there you have it. That's the hyperbola. I think it's really cool. They're kind of fun, tedious for sure. Lots of little steps. None of the steps are difficult. All of the steps are pretty easy. There's just a bunch of them. I think the hardest thing you could possibly see is this weird completing the square with factoring. Okay. So that's it. Again, I think I'm going to cheat and use somebody else's video for the last application problem.